Testing, testing. Hello, hello. Hi, Ed. Hi, Noir. What's up? Sorry, I said see you in 5 and then now it's been 10. Hello. We made it. What is on the module today? Let me know. Yeah, I think the internet is okay. Maybe some dropped frames, but good. Overall good. So let me go through some things as an update because I wasn't able, well, I didn't stream yesterday. Less about ability and more about me choosing not to. Testing. Oh no. Yes. Sorry. There. Sunday's off. I mean, I wasn't, it is Tuesday though. I am not, how do I say, an entity, so I can have my day off whenever. Yes. It is a Monday. So what you're seeing in the background here is that based on the last, which like on Sunday, my code didn't run, but I ran it the next day. So the code ran. I don't know if I need to rerun everything, but at least we have the model. I was thinking tokenizer, but it's not a tokenizer. On HuggingFace right now. So it's either we load that or we do something different in the second half of the tutorial. So this is us using, yeah, accuracy is pretty high, isn't it? I mean, I'm just using, which like, maybe, is it too high? I'm just using, based on the tutorial, which is token classification, we're using accelerate. Oh no, we're not. For now, we're using trainer, and then we'll be using accelerate in the second half. And just doing that after the prep and everything, and choosing like the arguments. We have 3 epochs. We can see the loss for the training. Is it going up? Anyway, this is going down. Validation training is going down. And precision going up, recall going up, F1 going up, and then accuracy going up bit by bit. So with just like 3 epochs, it's doing great. And that I had a failure somewhere in between. I thought it stopped because if you see, it took 7 hours and 20 minutes. So yeah, I had to like take care of it. So yeah, that's the first half of this token classification NLP task thing here. And we're doing named entity recognition. Second half is a custom training loop. Hello, Oliver. Hi. What's up? Yeah. So in the second half, we will be doing this right now, which is right now. Oh yeah, I should have read it the same way. Hi. Capital with 2 eyes. We are doing a custom training loop and not the training thing that already exists on using the trainer thing. Yes. So everything good? Maybe. Pretty okay. Great. I have to read more. Sorry. Stop saying sorry for a second. Have fun. Maybe drink some coffee while you're doing that. Great. something. Anyway, so yes, like, have you guys faced this issue of running a piece of code and then it going into infinite loop? It's happening to me right now on a on my other laptop that I am like looking at periodically. Okay, so for a custom training loop, we can easily customize the parts. It looks a lot like what we did in chapter 3. I don't remember anything from chapter 3. Like, stop making chapter 3 happen. With a few changes for the evaluation. Okay. Preparing everything for training. First, we need to build the data loader from our data set. We'll reuse our data collator as a function. Okay. And shuffle the training set, but not the validation set. Okay. Do that. So we're loading data loader from Torch, and our train data loader has the training data set. We're saying yes, shuffle, and our data collator, which we can go and look at, is the function, and then we have a batch size of 8. Up. It is something that we just called, that's it. And we've given it the tokenizer. Okay. And then, okay, so we have a train. Oh, okay. Now I understand. We have the training set data loader and the evaluation set / validation set data loader that we are not shuffling, but everything else is the same. Just the fact that they had different, like one of them is stacked, the other one is just written out. I thought they're two different things, but they're not. Okay. Next, we reinstate our model to make sure we're not continuing the fine. If I run this line of code, will things work? Because I think it's fallen asleep. I doubt it will. Because it shouldn't recognize the FN. It's here. Yeah. Anyway. We are reinstating our model. Are we loading the checkpoint? Tickle. I'll have to load it because I pushed it to hub. Yeah, I know. Sorry, baby, sorry. I guess I'll just have to start over, but not do the training thing. That I'm not gonna do. Do I need to do that? Oh, no. It doesn't work that way. I'll probably need to load the data set. Anyway, I'll get an error. I will expect that. Okay, so make sure we're not continuing the fine-tuning from before, but starting from... Oh, you're saying the one that is the main thing. Got it. The one that's the main thing, not the one that we did the thing. Not the one that we modified. Then we'll need... Yeah, so this is our model, and we're just loading it. We're giving it this thing, ID to label to ID, because it needs to know how many, like, based on the classification you want. Let's say this is named entity recognition, so it has location, organization, miscellaneous, and stuff. But like if you were doing sentiment analysis, it probably contain like positive, negative, neutral. Yeah. So these are the labels and IDs. And I haven't gotten the error yet. Okay. So we'll need an optimizer. We're using Atom W, which is like, oh, like, yeah, Atom and atom are the same thing, right? No, there's a W here. But with a fix in the way decay, in the way weight decay is applied. Cool. So that's our atom. Atom is the optimizer. Atom is for the win, a W. So once we have all of those objects, the objects are our loader, our model, and our optimizer. We can send them to accelerator. How long? Oh, hi. So I'm gonna need to do this for now. How easy are these things? I want to start learning Python and it seems a bit difficult to me. Good question. When you meet, like, starting to learn Python, do you mean you know programming and you're learning Python, or is programming completely new to you? Because I think my answer would be somewhat different, but also not that different, because I think you will learn programming through doing, and if you are interested in ML, then, I mean, well, this is natural language processing, not just ML. It is like, it's good to start where you want to start, and not somewhere that is too far. I say that while I start further than I should. But like, do you know about Free Code Camp? They have really cool tutorials for like super beginners, people with zero programming knowledge. So I don't know where you are, but yeah. Cool. Amazing. That's so cool. By the way, I'm sure you already know this, but I suggest that you use something like ChatGPT or Claude Sonnet as a personal assistant. So that I'm gonna show you Free Code Camp in a sec. So that, like, if you have quick questions, asking them is great. Sometimes it's probably not the most reliable thing, but like, it maybe treat them like a friend and less like a teacher. Python is very much English. That's true. It's pretty easy. I hope that I agree. I hope that we will have fun. Start with the most frequent numbers in a list. Oh, you are saying you're given an idea. That's cool. It's like telling kids to do all programming, and all programming is like telling a kid what to do, because if you tell it the wrong thing, it will do the wrong thing. That's the cool thing about computers. They're like kids, but better. Oh, are you telling me to restart the code here? Because that's what I'm doing. Yeah. My code, I am rerunning some things, not everything. Yeah. Language are syntax, that's all. Okay. Yeah, that language is pretty cool. Before I go back to my code, I do wanna go through get started as in login, because I'm not gonna do that. Okay. I mean, I already have an account. I just wanna show you the list of things that they teach. So, Oliver, if you're still with us, I think most of this is in Python. So like, if you are interested in web design, you can start here. But if you're not interested in web design and you're more interested in backend, you could probably jump here. So you don't have to move by write a program in Python to automatically restart the system in Windows, or, I mean, you could do that. Yeah, that's pretty fun actually, because it will show you how you can control your computer with programming. That's actually pretty fun. Yeah, if you're interested in data analysis or machine learning, this is actually TensorFlow, but I do recommend Codecamp. Like I've recommended Codecamp to a whole lot of people because it just has a nice interface. Yeah, yeah. Slow down and read this. Sure. Oh yeah, you've probably seen their videos on their channel. Like they have crazy videos. Like if you go to maybe playlist and like maybe look at Python, you'd probably see Python basics. Find some really cool stuff. This is yeah. Anyway, no one read books anymore. I don't read I don't like textbooks. I'd rather read fiction. I actually finished one yesterday. Mm. Okay, can I user model checkpoint? Do I need to prepare the label thing? I think I do. Yeah, all right. I'm just gonna run some of these things, like the list of features, the labels, and then the words and labels, which we can just see them. But we need I think we need those to create the label thing. Talking about program books. I'm sure people read. Okay, this is just a test. Word IDs, yes. No? Where's the thing? Oh no. Do I need to map again? I'll probably need to map again. This thing, which is this thing. And that thing I think uses this thing over here. Does it? Run and run. Okay. I don't, yes, we do need the collator. Where's the thing that I needed? These are our labels, okay. Oh, all right. There you are. This is what I needed, okay. So now I will go back to the end and then rerun this. And now it should work. Great. And there is our the video instructors are good. I can't be sure, but most of them are. Oh, sorry. Where are you supposed to be from? Probably Transformer, right? Let's check. Yeah, definitely Transformer. Okay. Doot. And then doot. Sorry if we are distracting you with our conversation because you needed to read stuff. Here's our Atom W. And then what did we do next? Yeah, we're just doing a accelerator prepare based on the like puzzle blocks we worked on. And if well, I'm not training on a TPU, but thanks for your concern. This thing. Now that we have sent our data loader to our accelerator.prepare, we can use its length to compute the number of training steps. Length of what? The data loader? Remember that we should always do this after preparing the data loader. As that method will change its length. We use a classic linear schedule from the learning rate to 0. Linear, what's wrong with me? A linear. Okay. So, chill, okay. We have a scheduler, interesting. Same number of epochs. Steps, based on the data loader, okay. And then training steps would be epochs and this update thing. Interesting. Then we put it in the scheduler. Linear optimizer, warm-up 0, which goes until learning rate. Is that what it said? Yes. And then we have the number of training steps, so you have to give it yes. Lastly, to push our model to the hub, we will need to create a repository object in a working folder. Can't it do it for us? Funny thing is, read the Python language doc, and oh, that's absolutely true. Python has great documentation. Sometimes documentations scare me because they have too much information. Like if I need to, I don't know, concatenate something, I don't need to know every parameter in that function, you know? So yeah, there are so many ways, and all of them are like, they lead you to the right path. So, we'll need to create, we said that, yes. First login, I am logged in. Maybe I'm logged out. No, I just logged in, okay. Yeah. Yes, we can give it the name. Got it. Just need to contain the username, which is, oh, we can do that. Hey. But that's, wait. Hold up. Here is our scheduler. Run. My repo name. Yeah, no. This doesn't exist, does it? Did I just become the Star Wars? You know the limits. Programming is more of an art. Probably. Yeah. It's like if you want to use pencil or a brush, it's all your choice. That's a cool note, huh? All right. So yeah, but am I not logged in? Really? Token equals true. Where? Here? Oh, okay. Token equals true. Sorry. No token found. You already logged in though. I really just logged in. Look. Log in. Oh, where did this J come from? Here. I logged in like just now. The token should be available. I mean, this doesn't work here. But I think there's a thing called just login. Let me try. Is it from the hub? I don't remember. Does this work? Yes. Perfect. Thank you. You have added and write code, basically, yeah. Docs give you limitations and rest you do out of creativity. Yeah. I don't know. Documentation intimidates me. I am a scaredy cat. Yay! Yes, that's my name. Thank you. And then, oh yeah, it's empty. What happened? Oh, repo not found? Are you kidding? Did we not just make it? First, oh, okay. Some chat that I need to get to. How much do you think is important to learn fundamentals of program before learning a programming language? 0. Not much, because you will learn it along the way, which that's why I'm saying use something like ChatGPT, because if you have a question about fundamentals, ask it right away, and don't dwell on it as much, I think. I don't know if my advice is good, but I hope it is. First step is important though. For me, if someone tells me to read book or read the doc, I might get scared to do programming and my motivation will be gone. Maybe, yeah, maybe starting with something fun is more important. I also agree with you on that. Read the docs when you need to read the docs, not as a first thing. That would be really dry, honestly. Like I said, I'm a scaredy cat, that's why. What's important is to learn, whatever the source is. Oh yeah, I agree with that. From a clean slate. Cool. I think JSS has a military style mindset, like do the correct thing. And I'm here saying, do whatever you want. I think both of them are like the right style, if that's what you want. I'm gonna need to create a repo apparently. We are training a model, so I'll probably have to make a new model because 404, this doesn't exist, so I'll have to make this. We say new model. This is the name. I mean, yeah, let's create it. 0 license. Whoa, what just happened? Anyway, can I run it now? Cool. And it's empty. Now, I've read and written the dry code. Driest. I'm sorry that you've written and read very dry code. That's why I always have coffee with me. And also dates. I love dates. Like date and coffee, that's heaven. Is this a Middle Eastern thing? Please tell me people have dates with their coffee. The thing that you eat, not the thing that you do. Hold up, I really need to show you the type of dates that I really like. Types of dates. Dates. Here we go. Look at this. The one that I have recently had is this one, right? It's so soft. It melts in your mouth. Butter. Really? God, there are so many types. Whoa. Do I know any names? Wow. Apricot. Shut up. This is really interesting. Open up. Oh God. We got a subscription, I think, from YouTube. While I'm out here looking at types of dates. How many are there though? Because like there are so many. Okay, there we go. I want to look at this picture. This is 25, but there are definitely more. Okay, maybe it was this one. See, now I can't tell the difference. Why is this called sukari? Is that the only sweet one? There are some types that I can't see here. Maybe it's this one. When you bite, like half of your teeth falls off. It's so like tough to bite. And then there are types you put it in your mouth and then it melts. The name date is called kurma. Kurma? Huh. Is anything called a kurma here? Like maybe it's after a type of date? I know none of these names and I feel ashamed. Wow. Helwa. This is called helwa, which is just sweet. Well, anyway, like if you just say, if we say like how many types there are, I think, should I just say how many? And then I'll stop. More than 200, yeah. I wish one day I will get to taste every one of them. Maybe not the. I'm very sure there are bitter ones out there. So yeah, I have my date and coffee right next to me. But if I have them, I can't talk. So yeah. I'll find a video and then have my date and coffee. Anyway, we are pushing it to the hub. Oh yeah, okay. We can clone the repository in a local folder. I don't wanna. I don't want to. I mean, I could, but I don't wanna. Maybe I should. Do I have to? Clone. Okay, yeah. And this is our output directory. We can upload anything we save in output directory by calling the repo push to hub. Some dates, you can have them with dark coffee, but I don't drink dark coffee as much. So yeah, I'm a scaredy cat when it comes to coffee as well. Because like they're so sweet. Anyway, this will help us upload at the end of each repo. That, yes, is cool. Hold up, Ed. I just understood what you said. Kurma is something that. No. Karma. No. You've written kurma, but I think kurma is the name that is used in our region. Yay! Reading about push to hub and epochs made my brain work that this is what you meant. So, our training loop. Yeah. I will do the push to hub, but not locally. So this is probably going to be not easy for me. Let's look. The training loop. We are ready to write the full training loop. To simplify its evaluation part, we define this post process function that takes predictions and labels and converts them to lists of strings, like our metric object expects. Okay. So in the post process, we have predictions. Where did predictions come from? My God. Did we call them anywhere? I don't remember. Hold up. Oh, it's coming. Oh, sorry. So it's coming from here. Detach CPU clone numpy. I guess that's how we may turn them into lists. And then labels detach CPU clone numpy. All right. Remove ignored index special tokens. From the beginning and from the end. Okay. And convert to labels. So these are the list of labels. And then our predictions. I don't really understand what's happening here. Yeah. Argument of the function. Thank you. What is this weird sound? Oh. I hope you can't hear it because it's an annoying sound. Setting up a repository offline out of the Git ecosystem as a backup. I mean, if you train your own model, then I absolutely agree with you, but this is just tutorial. And maybe you suggest that I should treat the tutorial as a real thing, which is a cool idea for someone who's a bit less lazy than me. But yeah, definitely I agree with you. Using Git, great. It helps. but also putting it somewhere that is yours is definitely, especially if it's a private thing. I mean, you can set things to private, I know, but yeah. Our training loop, after we do the post process, we make a training loop. Oh yeah, a progress bar. Talking about all other codes as well. Oh, I mean, even when you're using Git, if you're like using something like this is HuggingFace or like GitHub or whatever is out there, you still have the code offline on your device. Yeah. But maybe you're saying have a backup as well. No private when set to private. Yeah, that one's a bit obvious, especially for language models. Nothing is private, right? After defining a progress bar to follow how the training goes, the training loop has 3 sections. Let's look at the 3 parts that are behind my head. So let me zoom out a bit so that you can also see it. Yeah, okay. Set up a box on your own. Yeah, definitely. You can have a local or like a server and then send it there. Training in itself, which is a classic iteration over the train data loader, forward pass through the model, then backward pass and optimizer step. Okay, we go through it, we come back, and then we optimize. Evaluation, in which there is a novelty after getting the output from our model on a batch. Since 2 post processes may have padded the input, 2 processes may have padded the input and labels to different shapes, we need to pad across process to make predictions and labels same shape when calling the gather method. That's a funny method name. If we don't do this, the evaluation will either error out or hang forever. That's happened to me, right? Then we send the results to metric.addBatch and call compute once the evaluation loop is over. I had that 30 plus years ago. Oh, your own localized, that's cool. That's amazing. When did time sharing stop? Because I don't think things were cheap back then. Or maybe things were just smaller back then. I don't know. Saving and uploading. When we first save the model and the tokenizer, we call push to hub. Yes. We first save and then we push. Okay. Notice that we use the argument blocking equals false to push in an asynchronous process, meaning not to pause the loop and send it however possible. This way the training continues normally and this long instruction is executed in the background. I see. So this is our progress bar. I don't know why I love with the first local web server inside. Huh. Cool. Oh. Wow. Local web server. Yeah. So this is our progress bar. And we have it here. Oh, okay. I've seen it put like in the loop, but now it's just something that you just give it a +1. Cool. We're saying train, and then we're saying 4 batches in the data loader model. Here's your batch. This is our output. We're looking at loss, giving loss to. So this is back, and this is forward, right? We have the optimizer, learning rate scheduler. I don't know what 0 grad means, but optimizer here as well. This is the training loop. And then we have the evaluation part. For each batch in... Oh, we have train data loader and eval data loader. We did, yeah. Torch, no grad. And then we have the... I think I'm gonna need to understand what this means. I don't know what it means. And check. Just, do I say meaning? Yeah, okay. That's funny. So no grad has to do with gradient descent, maybe? No? Just gradient. Disables gradient calculation. All right. Thank you. That's all I need to know. Nothing else. Don't give me too much information. Just enough. Okay. Predictions. Here is our logits. We take predictions, we take labels, and then we do something with them. We'll see. This is the padding part. And then we call gather. We gather predictions and labels. No grad means you didn't calculate the grading for each tensor between an evaluation. You didn't need to update param. No need to calculate gradient. Even updating param. I see. After that's been a ton of unnecessary software bloat. Yeah, I agree about that part. I mean, I'm not saying my code is good. It's definitely not. So I'm a part of that. So we call post process, and then we say metric. So we have the labels and predictions. We gave them the labels and predictions, and then we compute metric. God, my brain hurts. And then this is the stuff. Grad requires approximately 2 to 3 size of param. Oh, so really, Matt. So you do this to make things faster, especially if you're in a test environment, right? Thank you. That's really useful. Okay, this is the code. And then in case... Oh, I didn't look at the saving and uploading thing, which is just... Okay. Wait for everyone. That's cute. Could test every tensor on different algorithms in real time and save the best for... Oh. Yeah. I would probably... I don't really know how to do that, but I think like in a research environment or like when you're trying to decide between models, this is like the best thing to do. Yeah. We unwrap the model, we save. I mean, this is save offline. So you can do this or skip it. And then we say push to hub. We save the tokenizer as well. Repo. Oh, we're saying repo push to hub and not model push to hub. Just realized. I don't like this. Anyway, did I run this? Yes, I did. Okay. Oh. What is... Oh, wow. We can see it moving around. Run the algorithm one after another and not one by one. Like add a line for each different type of model. Like that? I can see it go over. That's cool. And that is going to take 10 hours. Would you look at that? So, yeah. In case first time we're seeing a model saved, yes. Let's take a moment to inspect the unwrapping. Sure, I'd like that, yeah. So first line is self-explanatory. It tells the process to wait until everyone is at the stage before continuing. That's a cool thing. It will print the result in the same block code. Yes, add a line for each algorithm. Thank you. Yeah, so you'd have to like prepare the pipeline and have the algorithms all lined up. Okay, this is to make sure we have the same model in every process before saving. We grab the unwrapped model, which is the base model we defined. The prepare method changes the model to work in distributed training, so it won't have the save pre-train method anymore. Really? Undoes that step. Oh. Lastly, we call save pre-trained, but tell the method to use accelerator save instead of torch save. Thank you. I'm sorry for keeping you like for an hour. Please do your reading and have a great night. Thank you so much for sharing your insight. Who's everyone we're talking about here? Wait for everyone. Good question. Good question. Everyone. Basically, if any like background process is happening. Yeah, that's a good point. Is it multiple GPU or is it something else that's happening in the background? We can probably check the documentation. But before I do that, I want to finish reading this part. Once this is done, you should have a model that produces results pretty similar to the one trained with trainer. You can check it. We can. Okay, we shall do that. If you want to test out any tweaks, we can update the code. And then this is inference. So we can't do that because our model is currently running very slowly. So if I Google this, I should get oh, here is wait. Stop the execution of the current process until every other process has reached the point. So this does nothing when the script is one process. Cool. Cool. And that is the token classification. We still have the inference part, but that's not gonna end anytime soon. Before, I mean, the cool people who are keeping up with the Carnegie Mellon University, yes, please go there. Part will know that last time we went over the experimental design and human annotation thing slides, and you will also know that it directed us to, before like we go to retrieval and retrieval augmented generation, RAG, it directed us to, this was mostly about the scientific method, which is like very different from the rest of the lectures. It directed us to this page about how to write a great academic research paper. And I really want to watch this video instead of the lecture. So yeah, if that's cool with you, great. If not, you can like you can skip this one. So I'm gonna play this, and yeah, this is maybe from 8 years ago, but hey, no, these are main points. Actually, if I closed it. There are slides the PDF. That basically says everything if you don't want to watch the video, but I'm the type of person that prefers watching a video than reading. So yeah. So let's do this. Oh wow, we're 80. Should I put it in the chat if anyone's interested? I'll put this here. Oh shoot, I'll put this here in the chat because it has the other resources as well.
That's right, you got to wait. You can't quite finish it
sorry,
off.
Simon. And without further ado, I'll pass over to Simon because, of course, I don't have to introduce you.
Yeah,
No.
okay, good.
There are no subtitles. I'm offended.
Right? Okay, so, let's see. Have you had a good week? Yeah, plenty of food anyway. So maybe food for the brain as well, I hope. So the ability to write good research papers is absolutely central, not only to your career prospect, but also to doing good research. So what I want to do in this talk is just to make 7 very concrete, immediately actionable suggestions that I think will make your papers better.
Okay.
But the ground rules are the same as in the talk about giving a talk. This is slightly less recursive, which is, this is not a subject on which there are any right answers. Right, so there's I have no monopoly on truth here. So please ask questions or indeed make comments from your own experience as we go along. That would be more fun for me. We will still finish at 12, as mentioned at the end of the last talk. Okay, yes?
You said that there's no right answers. Are there any answers that are definitely wrong?
Oh, are there any answers that are definitely wrong?
That's funny.
Yes. Probably not, actually. To everything there is a counterexample. But I'm just...
Can I write it in the style of, like a bedtime story?
Just going to err on the side of being highly opinionated and saying things that I believe to be true, and then you can be free to disagree with them and fight with your supervisor about them. Okay, so here's the first thing. Just start writing. Right, so here is a typical plan for doing research. First of all, you have some idea, and then you spend some months or even a year or two developing the idea, and then you write the paper. That sounds logical, right? That's just good scholarship, isn't it? Utterly wrong. Here is what you should do, right? You have an idea, you start to write the paper. And in writing the paper, you think, oh, I didn't really understand that idea very well. That sort of forces you to refine the idea, and so the act of writing the paper sort of forces out the research, as it were. What can happen with this plan is you have the idea, you do the research, and after a year you start to write the paper, and you think, darn, 6 months of that year were completely wasted, and there's another 6 months left to do on bits that I didn't realize that I didn't understand. Right? So I'm a functional programmer. I like lazy evaluation. So this is like lazy evaluation, right? You start writing the paper, use that as a forcing function for doing the research. And not only is it a good forcing function, but it also it's a good way of trying to make yourself articulate what it is that you're doing. So I can't tell you how often I've started to write a paper and I've realized that something I thought I understood.
To add to his note, right for the research. Test-driven development. That's like that. Yeah, you're right. I mean, it says like write it while you're doing the research, but there are some other really cool notes when I read the PDF the other day. Actually, no, there was a note from Graham Neubig's lecture that was saying write your results like paragraph, like section before you've done tests, so that when you go back to it and you update it, you realize the assumptions you had and like you can now compare it. How useful is that? Like that video, I feel like I need to like watch it a bajillion times because it was so useful. Like, oh my God. What was I saying about this note that he just gave? Yes, the point about programmers, the rubber ducky debugging. The whole point is that you explain it to someone that's not inside your head, because you think you understand what's happening inside your head, But when you vocalize it and you explain it to someone who's not you, motorcycle passing by, you'll realize that explaining it to someone that's not you, you will realize like some things that you wouldn't when you're just inside your head. So I think this is the same idea, but on paper. You have some assumptions. If you write them down, see, let him cook.
How often I've started to write a paper and I've realized that something I thought I understood, I don't understand after all. But when you write it down, it all seems, by the time you actually get it in letters on paper, it seems more complicated than you thought it was, right? So it kind of crystallizes your ideas in a very concrete way. And that can make it much clearer where you don't understand.
I could place the other guy's accent, but I can't place his accent. The other guy was like Irish, I think. But this one I can't be sure.
And also another really good thing about writing a paper is it's something you can share with other people. While you've got all this stuff swirling about in your head, it's very difficult for anybody else to comment on it or indeed engage in any dialogue with you. You can sometimes do that one-to-one with somebody else. But often that's a bit disorganized. You start a conversation with the whiteboard. It's all very good, but actually, it's not something you can do in 5 minutes. So your act of setting out your idea in written form can be a very helpful way to open a dialogue with somebody. Does that make sense? Yeah.
For you personally, abstract first or last?
Oh, I'm going to say lots about content in a second. I'm just talking at the moment. So the question was, do you write the abstract first or last? Actually, last. But here I'm just concentrating on get started with writing early, because almost nobody does. Yes.
Related to this, would you recommend submitting your paper before you do the research?
Oh no, actually, go.
Submitting your paper before you do the research, as in your abstract doesn't have any results, or like just talking about results.
Going all the way to submitting it to a major conference.
So not to major conferences, but there are workshops or work in progress
Yeah.
workshops or
Maybe.
for graduate students, graduate consortiums.
Absolutely. So yes, for sort of workshopy things, do submit stuff that is in progress. Say that it's in progress, right? If you write it and you think, actually, this makes no sense at all, then you probably don't want to submit it.
Right.
But absolutely.
Can I ask who he is? Because I like him. I forgot his name. Anyone? Anyone in the comments? Anyway.
One of the nice things about computer science.
Sorry. I think that it should say so here. Simon. Oh, yeah. Simon. Functional programming languages and lazy functional programming. Cool. He's not a Microsoft person? Oh, he's British. What's wrong with me? He's British. From South Africa. Okay, I have a reason not to understand his accent.
Is that it's like a fractal. It expands like a snowflake ahead of you. So everybody, turns out, is working in a different part of the snowflake. Unlike, say, biochemistry, where everybody is converging on the boundary of science is very well defined. So people are kind of in competition. In computer science, you're much less in competition with other people, and so it's much easier.
I mean, you still are, but you're right. When it comes to real science, like science that is based on nature. I mean, everything is based on nature. God, whatever I'm saying, I can contradict myself. But like, I don't know, chemistry, biology, and stuff, and geology. Hello. The registration of papers, IA papers without experiments started, has been proposed to solve the replication crisis. Oh, so does that mean like someone does the registration and multiple people do the experiment? Or because like I know about challenges where workshop or a conference says, this is my data set, do this task on it, go. That's also probably but that does not mean replication, because everybody does different things, most likely. Also, hi Coffee, what's up? Another note about what he's saying about us being snowflakes and not going to the same route, which I agree to a point, because computer science is all made up. It's all made up. So you can make up new things, basically. That's what I'm trying to say. Who's with me?
Easier to share. So yes, share half-baked ideas. Just advertise them as half-baked. Yes.
What about positioning papers?
What about positioning papers?
Yes.
What does that mean?
You mean I'm trying to work in this kind of area?
Right. So
Yeah.
I have a great idea.
Yeah.
I just didn't implement the algorithm, but I want to get.
I love the fact that he's just answering the questions like out of the gate. Like, hit me. There's a huge bias with papers only publishing positive results. Oh my God, you're so right. Very few papers saying we tried this and found it didn't work. Absolutely. Also, I don't know, I haven't searched, but there should be like workshops / like things, maybe even panels about just submitting failure. Like that should be something that is encouraged so that other people don't do what you did. Anyway, I think I'm a bit passionate about this.
Get my idea out there.
Sure. So provided the venue is, open to that and you're upfront about what you're doing, absolutely, right? Just about communication. You're trying to say, is anybody else interested in this idea? Yeah. So yes, be open, speak early, but I'm almost, my main point here is really to do with almost communication with yourself, right? About starting writing, but also the dialogue with others is important. Okay? So the one thing just about having ideas is, I think I've sort of, by the way, more or less said this, that for me, writing is not an output medium, right? This is sort of where the paper is like the printer at the end of the algorithm, right? For me, writing is the way that you develop the ideas in the first place. It's the machinery of research, not the output, not the printer for research. Does that make sense? That's what works for me. Let's see.
Writing is the process, not the output, basically. Okay.
So if you're going to do this, number 2 is you need to know what your idea is. And that is often not terribly clear in advance, but it must be clear when it's finished. But I'd like to just articulate what is this business about an idea? So I think of a paper as rather like the talk that I was speaking about on Tuesday, as a kind of vehicle for conveying an idea from your head into, what's your name? Fraser. Okay, so my paper is a vehicle for conveying my idea from my head into Fraser's head, right? So it's like a virus. I put it on the paper, Fraser reads it, it goes into his brain.
Not the best example post-COVID, but thank you.
And if it's successful, it sort of takes root there. And he becomes a carrier, and he infects other people. So the paper is not a sort of way of getting research brownie points. It's an idea conveying mechanism.
It's both. We need brownie points, otherwise. Oh God, what is that? No thanks. We need brownie points, otherwise, some people will be discouraged.
Right, and with a bit of luck, Fraser, it's not. I put it in a rather dystopian view, but you might hope that Fraser is sort of excited about the idea and think that's cool and interesting, and maybe I could build on it and do new things. And I put Mozart up here because I think of Mozart wrote pieces of music that we are still. Let's think of them as his papers, right?
Oh, yeah.
And we are still reading his papers in concert halls, right?
Wow. I mean, yeah, basically the product of something. Yeah.
Just, of course, the interpretation is, huge part of musicianship. But the fact is that the ideas that he wrote down were so persuasive and catchy and interesting that people are still looking at 100 years later or hundreds of years later. I'll be astonished if anybody's looking at any of my papers in 100 years' time, but it would be very exciting if they were.
Will there still be papers in 100 years? I mean, I'm saying, yeah. Can we save our data for that long? I really hope so.
Yeah. So
I don't want another Alexandria library situation. And also, hi, I'm from Iraq, and we don't want another everybody just destroying our books. Yes, thank you. Goodbye. Oh no. Anyway.
And the ideas are more durable than anything else. You know, you may implement stuff, you may give talks, you may do a number of other things in research, but I think in a way that your papers are the most durable part of your output. They are the things that future generations of students may read and think, you know, Fraser's paper really changed my life. You know,
And think, God, they wasted ink for printing this. Fair, yes.
and I can point to some papers that did change my life. So, and that's in a way that implementations sometimes do, but not so much. So we often focus on tools and implementations. Actually, it's the papers that are the durable piece. And a bit about communication. If you have a great idea, because you're brilliant, which I'm sure you are, and you sit in your cell having the idea, and you do not communicate with anybody, then what are you?
I'm expecting him to answer this a bit harshly, but also, I love this man. His style of presentation is beautiful.
A heat generator, right? Not so cool, right? However good
You're not cool. That's funny.
your ideas, if you don't succeed in communicating them, they are not benefiting humanity, and that's what we're here to do. So it's not sort of, and communicating ideas.
The thing about ideas is that you can't implement all of them. Like, you have a limited amount of time and resources. And sometimes I get really, like, once in a blue moon, you get an idea and you think, wow, that's a really good idea. But you don't have anything to, I mean, you could scream into the void, but like I'm saying, post it online, but I don't know.
Ideas too is a way of discovering whether they're any good. You show them to people, they say that you know, sometimes they catch fire and spread, and sometimes they don't. That's a good winnowing mechanism. So, but if you don't attempt to communicate in as articulate a way as you can and persuasive way as you can, then you're hiding your light under a bushel. Don't worry, people will filter them out if they're bad ideas, right? But if you don't tell them, they don't have that chance. Okay?
Okay.
All right. So.
It's summer. It's summer in the northern hemisphere. Let's not be heat generators.
Then we have to wonder about this idea. So the worry is, if you look at other people's papers, you go to any conference or look at any conference.
I'm already intimidated, though. Do you see this title here? Don't be intimidated. I am already intimidated.
In a journal, you look at other people. Hey, that's a really good paper. That's a good paper. They have great ideas. All these people. They must be very intelligent. I am a mere worm. My idea.
Literally, this is what I think every single, I wouldn't say minute, but like day, definitely day.
Ideas are pitiful and weedy, and nobody would be interested in them, right? This is what everybody feels, right? We all feel that the stuff that we're doing is not very significant.
I think, even if it's really small, I perceive it that way. There is a small percentage of people who don't have that worm in their head and don't, like, they think whatever they have is the best. I think. I don't envy them, but I think they exist.
Unless you're a remarkably strong-minded or possibly arrogant person, but I promise you that most computer scientists feel this sense of insignificance by compared to the glorious reality of research in your field. But I think the bottom is important, that even if your idea seems a bit weedy and insignificant, just write a paper about it anyway. Right? You're not committing to publishing it at a top-tier conference. You're just committing to writing it. When you write it, it may turn out indeed that it was a weedy and insignificant idea, and then not much is lost, right? You've just articulated it clearly. But maybe, and very often this happens to me, I start writing a paper about something I think is not so cool, and then I find it actually takes me 12 pages of double-column, 8-point font just to explain enough about what it is for it to be comprehensible to other people. In other words, it's turned out to be bigger and more interesting than I expected. That's very common, right? Occasionally you discover, no, it isn't, but often you will. So this is another get started thing. Don't wait until you have a good idea to write something. Write stuff about any idea. Have you got the message there? right? Don't wait to have a good idea, because nobody does. We only discover that they're good ideas later.
When we do research about them and flesh them out? Okay.
Right?
Right.
They're really important, because everybody has this problem, and it's very disabling if you wait till you have an idea that you think is cool enough. Okay, let's see. Last little piece about ideas is that when you write a paper, by the time you are finished at least, you must be clear about what the idea is. You may not be very clear right at the beginning. This goes back to the question about abstracts, right? So that but by the time you've finished, you really ought to be able to articulate what your idea is. I'll have more to say about that later. But the bottom point is the important thing. Sometimes you find, I read a paper and I think, oh, well, that's got several ideas, and they've got so smushed together, they've been sort of squeezed into the compass of a 10-page paper, and you haven't done justice to any of them, right? So if you have lots of ideas, praise be, write lots of papers. This is not salami slicing. That is writing many papers about one idea. That's writing many papers about many ideas. Okay, so resist the temptation to just skate lightly over many ideas. Just try to focus and be clear what the idea is. Sometimes there's a very closely related family. This is a kind of nothing is completely true, but this is a good baseline to start from.
Right. I'm gonna talk about a meme which is no idea is fallen out of a coconut tree. But also, focusing on one is pretty...
Okay. And so this is Joe Touch. I gave a nice talk I was at in which he said, do you remember the hunt for Red October? And where Captain whoever it is says, just one ping. They send out a sort of some bounce to another submarine. Only one, right? So that's and the ping is the idea. So here's a good exercise. When you read somebody else's paper, close the paper and try to say, what is the idea that I learnt from that paper? What is the key thought in that paper? You should be surprised how hard it can be. Indeed, I have found myself, as a reviewer, writing in my review, I believe that the key idea in this paper is da-dum-da-dum-da-dum. But I'm not really sure, because the author didn't really tell me. And so I write that in my review because I want the author to think, well, that wasn't my key idea at all. So, the reviewer completely misunderstood. They might then reshape it. They might think, yes, that was the key idea. I should make it more explicit. So, I would encourage you to be totally explicit and to write something that says, here is the key idea. I
think that was the same advice given in the lecture by Neubig, which said, was it reason or was